So design patterns um, is a programming strategy, a programming technique that focuses on multiple repeating programs, multiple repeating problems. So as you build application, there are multiple scenarios that you're going to encounter, and in these scenarios, they have acceptable common solution, right? Design patterns say that there are 23, 24 design patterns. I think there are 23 design patterns. And in these design patterns, they are commonly occurring problems. So, okay. Yeah, there are 23 design patterns. I'm sorry about that. So these patterns, they are commonly occurring problems, and their solutions, they are pretty standard. Then before that, I want to talk about designing itself and patterns themselves. So let's assume, Nathan, can you go mute? Thank you. So let's assume that you are building a house. So the house itself is probably going to be a square or rectangle piece of land, and you want to have, say, bedrooms and kitchen and living rooms and play areas and entertainment areas, library in the house. The question is that for a house like this, where how would you build it, right? So let's assume that this is the living room, this is the entry door. Would you, right? Would you put the kitchen over here and the bedroom over here? So like this is the bedroom, this is the kitchen, right? These are some appliances that you have, and these are the bedrooms, and there is another door for the bedroom, and this is another probably bedroom over here, right? So the person who is going to use this probably is going to enter over here. It's going to cut through the energy. It's going to come inside this room. It's going to cut through the kitchen, right? I did not kind of like this approach because there are people who would be using, would be sitting here, and then the person who is entering is going to cut through these people, and probably they are watching TV, they are using something. It is going to interrupt the normal flow of the house, right? So this is where the design pattern concept came from. When you speak to architects, their intention, their objective is to create a house with minimal distractions. So what they propose is that you separate out where you want to enter from, right? And then the doors of the house should be created, or these spaces in the house should be created in such a way that there is minimal energy cuts. There are people are not walking in between other people, and these sections, they are separated out in such a way that they are functional, they are cohesive, they are logical. And then it's the same concept that we want to apply when we are building software. Uh, there are at least three types of patterns. Those 23 design patterns, they are divided in three separate categories, right? The first is creational pattern. Right. The second is behavioral pattern. Third is structural pattern. So creational pattern is going to focus on the creation of the objects. There are multiple ways you can create an object. Um, so let's talk about a singleton. A singleton pattern is where you're going to have across the application one and only one instance of the object throughout the life cycle of that particular that particular instance. The reason you would want to do this singleton is because this object is doing something straightforward. Let me give you an example. Right. This object represents something that cannot have multiple occurrences in the system, like say a president of the country. All right. So you don't want to create multiple instances. Anytime anybody comes and says that, hey, I want to talk to the president, you are not going to create a new object, new precedent, something like this in the code, right? You are going to refer to some spot in the code, and that spot is going to give you that one single precedent that you have for that country. All right. So with that, let's jump into Visual Studio, and we're going to write some code for that. So I'm going to select a simple console.NET Core application. I'm going to call it design patterns dot singleton. And from the solution, I'm going to delete this part. I can live with .NET Core 5. All right. Let's go ahead and create a class. I'm going to call it app. And in the main function, I'm going to replace that. All right. One thing that I wanted to show you for a while is that the C#9 syntax is a little forgiving, and you don't have to do any of this. You can simply come and paste your code here. I've not done this before. Probably I'll have to add a using statement, right? But you don't require anything in the entry point class anymore. You can simply come and run this application, and it will run just fine. Okay, because run is not doing anything. We are not seeing any output, but then this application runs perfectly fine. I'm going to undo this because there are things probably that I'll be doing over here. And over here, I'm going to type var app assigned to new app. And then we're going to do app.run. All right. In the run function, I want to figure out a way of, I want to figure out a class that is singleton. And sorry about this, public class precedent, and probably this precedent is going to have a name. All right. Now, every time I call this precedent instance, precedent, it is going to create a new object for me. And there is a special syntax that in the curly braces, if you put the name like so, right, I'm just going to put my name, right, it is going to give you a new precedent object. If I copy and paste and repeat this code and give it a different name, right, these two objects, we're going to have two separate objects. So let's just go ahead and print the names, right, and we are definitely going to see two separate outputs. All right, we don't want that. We want to take away the ability of creating the present object from all the other code. And if you remember the access specifiers, a public access specifier is going to expose things to the outside world. Anybody who has an instance of this will be able to access these properties. Now we are okay with the name property getting accessed from the outside, but then we want to take away the ability of calling the constructor. And then if you don't want anybody to call the constructor, you are going to make that constructor private. Now, if I do this, notice something in the code. By saying that it is inaccessible due to its protection level. All right. Now that the ability of calling the new function has gone, they cannot do anything about it. They cannot pass a string because that constructor does not exist. It's going to say that there is no constructor that takes one parameter, right? So we have kind of solved problem number one, that you cannot call the constructor. Now, if you want to create an instance, you will have to do something tricky, and then you're going to give it an object called create president, and then this function should have a return type of president, and then this is the only function that can create a precedent for us. And then over here, if I return precedent, we have created an object as well. So let's go ahead and replace this function, this call here, with the create function. Now, for calling this function itself, I will require an instance of the precedent class because this is a member function. But then there is a special type of function that does not require an object. And I think you have seen that multiple times. It is called the static function. So the way we're going to call it is we're going to say precedent dot create precedent, like so. But then the error message says that an object reference is required for the non-static field, right? In turn, it is saying that if you convert it to static, it is fine. You'll be able to call this function. So what we have done is we have defined a constructor, we've made it private. And because this is private, nobody will be able to call it. This function is not going to do much, right? So then our ability of creating the object is taken away, and then we provided a public static create function, which is going to create the object and return it to us. Now, I don't want to give the ability of creating a precedent to all these objects. So I'm going to pass the name as a parameter. I'm going to accept the name over here. Now, you can modify the name property over here, but then I would prefer passing the name to the constructor like this, and probably save the name this way, right? And now that it is a constructor with one parameter, we will once again be able to call new precedent. I guess so. All right, so there is no default implementation for this. Okay, so ignore this part. I thought that a default, as soon as you add a constructor to a class with any number of parameters, all the object-oriented programming languages, they take away the default constructor. So if you don't provide any constructor, the C# compiler, the object-oriented programming, is going to give you a constructor with no parameters, right? So this is coming from the compiler side. But then as soon as you add any constructor, all right, this default constructor is taken away, right? So because our constructor is defined and it is taking a parameter, we are good. We have created a precedent object and we are returning that. So let's see if this part of the application works. I would want to see my name as the output, and it seems to be working fine. Let's close out of this and try creating another precedent. And then this I'm going to call it John. And I can uncomment this. If I hit Control F5, all right, it is still creating two precedents, right? So we have kind of fixed the problem that you cannot call the constructor, but then we have exposed the constructor through a static member, and now there is no stopping of creating these objects. So what should actually happen is that this function here should track the copy of that single instance, which can be returned if the function has already been called before. And when the next request comes, it is simply going to ignore it and keep returning the same precedent instance that we are creating on this line. So in short, we would want to persist the result of this particular object for the life cycle of the class and not the object. And the way to do that is we're going to create another member that's going to be private and static. I'm going to call it underscore precedent, and it's going to be of type precedent. All right. The first thing now I'm going to do is I'm going to check if underscore precedent is null. If it is null, only in this case, I'm going to call the function. I'm going to call the private constructor that takes one argument, and I'm going to instantiate that object. So over here, I'm going to replace this code with underscore new precedent, and the return statement, I'm going to move over here, return underscore precedent. Make sense? Now I can hit Control F5 and notice that for both the print console.writeLine statement is the same name that is getting printed. So let's go ahead and debug this code. I'm going to hit F9 and probably another F9 over here. Now with F5, I started debugging. Now let's go ahead and do F10. This time I'm going to hit F11, and F11 took me inside the create precedent function, which is what we are calling. The name here is Zia. It goes inside, it checks if precedent object is null, and this time it is null, so it's going to come inside. It is going to create the precedent object. If I hit F11, it is going to go inside the constructor with the same name. It is going to initialize these members. It's going to come out, and we are returning a precedent with my name. Make sense? Now it comes out, and it once again sees a create precedent statement. Right? So it comes here, it assigns the value John this time, but then this condition is going to fail because there's an object that already exists, and because the condition didn't match, we are returning the same object with my name in it, right? So even if you are calling create precedent, the function has little intelligence. It knows how to check if the precedent has already been created, and because it is created, it's going to return the same object. And during both these calls with P1 and P2, we are going to use the same. We're going to use the same object, right? And that is our output on the screen, right? We have taken away the ability of creating the object by making this private, provisioned a public static function, which is going to return the object, and we have applied some condition using the static keyword of having only one instance across the entire life cycle of this class or this program. All right, so a little tricky program, but then this is Singleton. You would want to have only one instance of that particular class throughout the life cycle of the application. But this is the long and the old way of doing it. There could be multiple threads that will be accessing the create precedent function, and they can run into a race condition. And to avoid race condition, a simple trick is that you declare an object. Okay, I'm just going to make another private static object. I'm going to call it obj, or I'm going to call it lock. I'm going to put a create lock over here, and this create lock is going to come, and inside this lock statement, it is going to protect this creation. So I told you the last time that C# is going to keep coming in different formats. So this is another C# concept that I did not show you when we were discussing C#. We only discussed the basic patterns, but then lock is going to prevent this particular section of application from getting entered by multiple threads, right? So that if you have multiple threads that are requesting a precedent copy, only one thread is going to come inside and create the object and is going to return it. So with that, our code is going to be safe and secure across multiple threads. So that is one last tricky piece of the Singleton design pattern. It's going to have a static lock object. It's going to have a static object of the class itself, the one that you want, Singleton, and it is going to have a private constructor, and it's going to have a public static create function. Now, the generic term for this kind of function, which is creating the instance for you, is called a factory method. So what we've done is we've added a factory method inside this class, and that factory method is restricting the object creation, right? So that is the Singleton design pattern for you. But there are other ways in which we can achieve the same functionality. And this time we are going to depend on the .NET framework. So let's go ahead and install an extension. Microsoft.extension.dependency injection. Yesterday, we saw that dependency injection is going to create objects for us with all the dependencies that it has, right? So if we want a single instance of an object, I mean, why depend on a function like this, which is doing a lot of heavy lifting, a lot of groundwork for us? Why not rely on a framework? And we're going to do that here. So the way we created that is we defined an object called services with new service collection. This service collection is present inside a namespace. Control dot is going to show that to us. Double click, and then it's going to get added to the list here. Excuse me. In this service collection, I'm going to say services, and I'm going to do dot add. And then yesterday we used scoped variable. Now the scoped member, but there are other members as well. The one member that we're going to use today is called add singleton. Right? This add singleton is going to take the name of the class that we would want to be a singleton. And if I do this, it is registered as a singleton. So now we need a provider. That is build service provider on the services collection. Now, if we tell the provider that provider, I'm going to copy this code, paste it over here and comment it out. We're going to say provider dot get service, and we're going to pass precedent over here like this. Now, because precedent does not have a public constructor, it is going to complain. So we're going to replace this thing with public, and passing parameters through dependency injection is a little difficult. So I'm just going to remove this for now, and even this. And let's come back to our main program. So what we've done is we have added dependency injection, which is going to take away the object creation from us from the solid principles section from yesterday, right? We initialized the service collection. We told the service collection that for a precedent, make a singleton, and every time somebody requests an object for this, give it that one single object, right? And then we got a provider. A provider is the one that gives us these objects. I'm going to say precedent one, or I'm just going to call it P1. And over here, I'm going to say P1.name assigned to Sia. And I'm going to repeat this code for the next copy. I'm going to say P2 and P2.name as, say, John. Now, if I put those two console.write lines, P1.name and P2.name, and if I run the application, I'm going to see the same name twice, right? This is because both these get services, they return the same object, right? And then because we got the same object, we are working on the same reference copy. When I modified the name, it went ahead and replaced this name with this new name here. And with both the object, we got the same result. which indicates that registering a service with add singleton method is going to inform these providers that there is only one instance of this thing. The advantage is that it is fairly straightforward. You register it and then you use it. Right? You don't have to worry about all these nuances that you will have to create a lock. You will have to make sure that this is static and there is a create function that you'll have to add. One of the tips that I would want to give you right now is avoid writing a lot of code. Earlier it was like the more the lines of code, the more the applications are going to get paid. But then enterprises, they have eventually realized that writing more code means more maintenance, and then you want to avoid maintenance because maintenance is like extremely costly. And to avoid maintenance, you should not have code to begin with, right? So a good strategy is to depend on frameworks like dependency injection from Microsoft and use those dependencies to have all those inner working taken care of, right? So that is dependency injection using two ways. One, using custom classes, and second, using DI framework. Let me go ahead and pull up a list of dependency injection frameworks. All right, so I told you in the beginning of the session that there are 23 design patterns. They are categorized in three types. This is the creational pattern. This is the behavioral patterns. These are behaviors, and these are structural patterns. Right? What we have seen is this pattern here. We discussed a term. It's called a factory method. I don't want to use factory method because factory method is a function, is a design pattern itself. But then all these yellow ones, they are some form of factory. They are going to have a function like create instance, and they're going to create an object for you. A factory method is what we saw. Singleton is a special case of factory method which controls the instance that it is going to return. Prototype is you have an object instance already available with you and you want multiple copies of that object. So that's when you use prototype. Abstract factory is going to create a family of objects. So in a hierarchy of objects, so suppose you are building an X window system. An X window system is something like this. It's going to have GUI, it's going to have buttons for closing, maximizing, right? It's going to have some buttons inside it. It's going to have forms, right? But then this X window system, you would want it to be, say, cross-platform. So you want to support, say, the Linux platform and the Windows platform, right? There are definitely differences between these two operating systems. So when you are creating a UI of this form, you are going to inherit and you're going to write multiple pieces of code. So you're going to say X window for Linux, button for Linux, and then a form for the Linux operating system. On the parallel lines, you can repeat all of this for Windows, right? So X window for Windows, X window for button, X button for Windows, and X form for Windows as well. When you have such parallel families running together, you would want to start using the abstract factory method. So depending on what operating system you are in, it is going to call these three objects together, or it is going to call creation of these three objects together. You cannot mix and match. Once you have told that I'm running Linux, it is going to go ahead and create all the objects for the Linux operating system. And if I can pick up this function, go ahead and copy this and paste it over here. All right. So instead of create precedent, it is going to be create. It's not going to be precedent. It's going to be create X window objects. And then instead of the name, we are going to pass the operating system name. And in this operating system name, we're going to compare over here. And we're going to say that if operating system name equal to Linux, it is going to create those 3x window Linux object. So probably a new keyword here and another new keyword with the button for Linux and with a new, say, form for Linux. And in the else part, else if part, it is going to once again compare that the operating system name is Windows. And if it is Windows, it is going to pick up these 3 objects and put 3 new statements underneath this. So all these patterns, these 5 design patterns, they have a similar thought process, a similar strategy of how to control the object creation. Right? You are always going to see one or the other overlap or overload of this method. It knows some form of discrimination about what you want to get created. And when this function returns, it is simply going to return the abstraction. So I hope you see the inheritance diagram there that there is an X window system, right? And this empty triangle here indicates inheritance. So if you remember that there's a parent and then colon and then the other way, there's a child colon and then the parent class. So this X window system is going to take the parent spot, and then C is going to have multiple implementation, one for Linux, one for Windows. So this empty triangle here indicates inheritance. So it is C Linux or C Windows, and then they're going to have the same members coming from this. And this inheritance hierarchy is going to be repeated for all the generic controls that you have. And the return type of this is going to be the X window system, right? And the object that we're going to return, they're going to be concrete object. So we're going to return new Linux probably. And because there is an inheritance hierarchy going on here, we will be able to do the programming using this part. So it is what we already saw in the solid principles demo, that we can create an object of a child class, say a Facebook message writer or a Twitter message reader, and assign it to something generic like iMessage reader, iMessage writer, and the application would work just fine. We only have to control how those objects are created, and because of the Liskov substitution principles, things will kind of